In this function, we have a polynomial where the exponent is higher in the denominator, so we call this a bottom heavy rational function. So this one is bottom heavy, and whenever it's bottom heavy, our end behavior will approach 0. So we have a horizontal asymptote at y equals 0, which means that expressed as a limit as x approaches positive and negative infinity, f of x will approach 0. Okay, so now let's find our critical points. We always factor if something can factor. In this example, it's our denominator that can factor, and it would factor down to x minus 2 and x plus 1. So we have vertical asymptotes at x equals positive 2 and x equals negative 1. So we have 2 vertical asymptotes. We have our root, and that comes from the numerator. When we set the x equal to 0, we will have one x-intercept, and that's at 0, 0. When we find our y-intercept, by substituting in a 0 for x, we end with 0 over negative 2, which is also 0, 0. So let's go ahead and plot these critical points. So notice that we have our 2 vertical asymptotes, and then we have our horizontal asymptote, but the horizontal asymptote is only on the ends. It doesn't go in between the asymptotes, in between the vertical asymptote. And then we only have 1 point, so we will need to create a t-chart. So we only had 1 root, so because we only have 1 ordered pair, we need to choose x values so we can get a clearer picture of what's happening in this function. So we're going to use numbers that are on the left side of my first asymptote, so numbers that are less than negative 1. So I chose negative 1.5 and negative 3. And then I need to see what's happening in between my asymptote. So I chose a number in between negative 1 and 0. And then I chose a number in between 0 and 2. So that represents that. And then also we need to see what's happening on the right side of x equals 2. So I chose 2.5 and 4. Substitute these numbers into the function to find the corresponding y values. So these are the corresponding y values. So I'm going to go ahead and plot these points. And the main thing we're really trying to figure out is where is the function. So we want to know, is it greater than 0 or less than 0? And we can see from these y values that at first we have a function that is below the horizontal asymptote, and it's approaching 0. So we have, oops, something like this. And because of the asymptotes, this graph really can't do anything except go straight out as it approaches 0, and then it's going to go straight down as it approaches the vertical asymptote at x equals negative 1. In between, it starts off at 0.4, and then at the positive 1, it's here. So that tells me that it's increasing. It's going to go straight up, and then it decreases. It goes straight down. So it looks like a cubic, but it's not a cubic. And then on the far right, our y values are positive. So at 2.5, it's approximately 1.4. And at 4 is 0.4 positive. So again, it goes through those points, it goes straight out. So that is our rational function. So now let's look at our domain and range. For the domain, because of the two vertical asymptotes, we have two places where x is undefined, so we need to break it. So we start at negative infinity. It goes, but it cannot cross this line. So negative infinity to negative 1, union, negative 1 to 2, union 2 to infinity. For our range, because of this middle function here, our range is actually all real numbers. So here on the left, it's not going to reach 0, and on the far right, it doesn't reach 0, but it does actually in the middle. So this range would be all real numbers. So now let's look at a function that has a higher exponent in the numerator. Looking at this function, notice we have the x squared in the numerator, so this is top heavy. When it's top heavy, it has an oblique asymptote or a slant. So we have to do a little bit of synthetic division in order to find that asymptote. So let's start by factoring. Can we factor? Remember, if you cannot factor, you can use the quadratic formula. You can also use it if you can factor, but there may be some questions where you have to use the quadratic formula in order to factor it. So the numerator factors down to x plus 3 and x minus 1. Write that over here also. Alright, so to find our x-intercepts or our roots, we need to look at our numerator. And when we set both of those equal to 0, we have 2. One is at negative 3, 0, and the other one is at positive 1, 0. Vertical asymptote, we only have 1 in this example. We set that x plus 1 equal to 0, and we get x equals negative 1 as my vertical asymptote. The y-intercept, substitute in a 0 for x, and you have negative 3 over 1. So your y-intercept is at 0, negative 3. And now let's find our slant asymptote. So when we do our slant asymptote, we set our denominator equal to 0 because we're dividing x plus 1 into the numerator. So we set that equal to 0, we get negative 1. That goes on the outside. And then our three numbers are 1, 2, and negative 3. So when we do synthetic, we bring down the first number, multiply negative 1 times 1, and then you add and you get 1. You really just need the first two because we're interested in the slope and y-intercept. So this represents the slope and B is your y-intercept. So you have an oblique asymptote or slant, and that's going to be at y equals x, 1x plus 1. So let's plot our critical points and graph our asymptote. Okay, so we have our oblique asymptote graphed, starting at the y-intercept of 1 with a slope of positive 1, and my vertical asymptote, and then I also plotted my x-intercept and my y-intercept. And now this is the place where you need to choose your x values so you can get a clear picture. So I'm noticing that I only have one point on the left of x equals -1, so I want to choose a couple more points over here. So I am going to substitute in -2 and -5. And I'm also only going to put 1 point over here because I can kind of see what's going to happen there. But I want to put 1 more point, and I'm going to substitute in a +5. Go ahead and substitute your x values into your function. Okay, so after I did my substitution, I got the corresponding y values. I've already plotted those points. Remember that it's going to just go along that oblique. It's not going to cross it. And it's going to do the same thing on the right side. Comes up really close. Then it extends out. And that is our function. So now let's look at our domain. So because our x value cannot equal -1, we do have a break in our domain. So our domain will be -infinity to -1 union -1 to +infinity. But when we look at our range, there really is not a y value that we will not reach because this is a oblique asymptote. So our range will be all real numbers.